Continuing with our Airbnb example, remember that we had two categories, okay? We had a superhost and non-superhost. So for superhost, the value was 1, and for non-superhost, the value was 0 on the superhost dummy variable, okay? So what we had was, with two categories, we had the superhost variable, and this variable was 1 if superhost and 0 if non-superhost. And we could have made another dummy variable which had been non-superhost, which had been 0 if superhost and 1 if not superhost, right? So how can we expand this to 3 or more variables, okay, or categories, okay? Because for two categories, two categories, we have chosen to keep one of these dummy variables, and the other one we did not need, right? Because you see here that remember that we talked about collinearity, okay? Because these are perfectly collinear, and you immediately see that when superhost is 1 and non-superhost is 0 and superhost is 0, non-superhost has to be 1. Okay, so they are perfectly collinear with a covariance or correlation of -1. Okay, so that's why you only keep one of these dummy variables in the data set, and you see that immediately this one variable, the superhost variable, it gives you the information you need, because from this one variable you can see whether or not a data entry contains a superhost or non-superhost. Okay, so using this technique, we can actually include more than just two categorical variables. Okay, so what we do then is that we use category 1 is a dummy variable, right? Category 2 is also a dummy variable, and so on. And we choose one of these to be the baseline category, okay? And the baseline category is removed from the data, okay? Or we don't make a dummy variable for the baseline category. So for example, non-superhost was the baseline category. Okay, so if the host was a non-superhost, then the superhost had 0, right? 0. And it's the same if you have 3 or more categories. You just include, or you, for example, category 1 is the baseline, okay? Then you include all the other categorical dummy variables, okay? So these are dummy variables So, which means that category 1 has been chosen to be the baseline category. And then we include all a dummy variable for all the other categories. Maybe this was 1 and then 0, 0. This was 0, then 1, and then 0. And this was 0, 0, 1, and so on. Okay? So, and remember that when we had a superhost dummy variable, then the coefficient for the superhost dummy variable was a change relative to the base case, right? So the coefficient on the superhost dummy variable was the change in intercept between the base case, the non-superhost, and superhost. Okay, so let's just make an example here, and we want to examine how prices vary by property type, and we have three categories. Okay, and now already you know that you have to choose one base case, a base case for which all the other dummy variables are set to 0. So for example, we choose apartment as a base case. Okay, so we choose apartment. Let's see, as the base case. No dummy for apartment. Okay, so since we choose apartment as the base case, then we have to generate the like a dummy variable for the two other categories, which means that we have to write generate and the name, for example, house, and this is the variable name, house, and the value of house is equal to property type and if this is equal to house, and here you have to, well, it's capital intensive, okay, or sensitive. So if it's equal to house, then it's going to be a 1, and if it's not equal to house, then it's going to be equal to 0. Okay, it will return a value of 0. And generate, and we have other, and here if the property type is equal to other, then other contains a 1, and if property type is not equal to other, then this is false, then other contains a 0. Okay, so for example, if we show that here, we have a variable, it's called house, and if we look at house and the first data entry here, it's an apartment, so property type equals house is false, which means that we have a 0 here. And this is an apartment, and this is other, so those are 0, and here you have a house. Okay, So house is 0 for any other thing than house, and 1 given the data entry is a house. And other, the other variable is 0 for apartments, and 1 for other, and 0 for house. Okay, and we have 3 categories, right? But we only need these two dummy variables, because immediately you see that, well, if you have an apartment, then house is 0 and other is 0. So from these two variables, you can actually tell if the data listing is an apartment, an other kind of property, or a house. Okay, so in general, to distinguish J groups, we need to include J minus 1 dummy variables in our regression. Okay, so you see that here you can just if you have J minus 1 dummy variables, you immediately know which well, category each and every data point lies into, okay, or fits into. Okay, so and for this example, we have apartment as the baseline category, which means that the coefficients on house and other, they are relative to the apartment. Okay, relative to apartments. So let's look at a regression which regresses price, which is our y variable, on bedrooms, house, and other. These are our dummy variables. These are our dummy variables. And we have house times bedrooms and other times bedrooms. They are our interaction terms. Okay, so what we see is that the F statistic tells us that our regression actually explains a relevant or a significant part of the variation in y, in the prices. So then we can go down here and look at the t-stats of the coefficients. Okay, so we have a coefficient for bedrooms, and this is the coefficient. Well, the price, the extra price per day given 1 bedroom extra, right? And we see that some of these coefficients are not statistically significant on the 5% level, but that's kind of beyond the point here. In real life, you would probably not keep these, but let's move on to the regression equation. Let's see, that you would have the price. You would have the price plus the intercept, which is 445, plus the slope on bedrooms, 281, times bedrooms. Okay, and now you would go on to the dummy variable, so you would have negative 47 times house. And remember that house is a dummy variable, so it's either 1 or 0. And you would have plus 40 times other, which is also a dummy variable, so it's either 1 or 0. And you would have plus, or we can do that down here, plus, let's see, 39 times house times bedrooms, which gives you the, remember that house times bedrooms, it's different from 0 only when the house dummy is equal to 1. Okay, when the house dummy is equal to 0, then this house times bedrooms is also equal to 0. Okay, plus 12 times other times bedrooms. Okay, so that would be our sample equation. Okay, our estimate of the price. Okay, so how do you interpret these? Okay, well, what you can do is that you have the dummy variables either 0 or 1, right? 0 or 1, and no, not the bedrooms, but the other. Okay, okay, so, and what is the estimated equation for property type apartment? Okay, so if the property type is apartment, then house equals to 0 and other equals to 0, and because house and other equal to 0, then the product house times bedrooms is also equal to 0, and other times bedrooms is also equal to 0. Okay, so what we have is the price equal to 445 plus 281 times bedrooms, and that's basically it, because what you have is you get minus 47 times 0 plus 40 times 0 plus 39 times 0 times bedrooms plus 13 times 0 times bedrooms. And if you just join it together, you get 445 as the intercept, and the slope is 281 times bedrooms. So this is the estimated equation for the type apartment, and this is the base case. Okay, the base case when all the dummy variables are equal to 0. Okay, so what if the equation is for property house? Okay, then house equals to 1 and other equals to 0. Okay, so then you have the price equation equals 445 plus 281 times bedrooms minus 47 times house, which is 1, plus 40 times other, which is 0, plus 39 times house, which is 1, times bedrooms, plus 13 times other, which is 0, times bedrooms. Okay, and if you join them together, then you get an intercept of 445 minus 47 times, no, plus the intercept is 281 plus 39 times bedrooms. Okay, so that would be the estimated equation for a property type house. So if you would estimate the price and you know the property type is house, then you use this equation. Okay. So for example, what we have in the Airbnb plus 3 categories example is that 47 is the difference in the estimated intercept between apartments and house. Okay, let's see. Oh yeah, house was negative 47. Yeah, negative 47. Okay, then I have to, yeah, negative 47 here. Okay, so this is the difference in the estimated intercept between apartments and house. Okay, so the coefficient on the dummy variable is a difference. It's not the level. Okay, and the 39 is the difference in the estimated slope between apartments and house. Okay, because this is the coefficient on house times bedrooms, and this is the coefficient on house. Okay, so the interpretation of the estimates is similar to the interpretation of models with 2 groups, as you remember, with hosts and superhosts. And this means that you can look at the coefficient on house and see is the intercept between the regressions of properties house and properties apartments, are they different? Okay, and this is here. Okay, so this is the statistical test for the coefficient on the house dummy variable. Okay, so it really says, are is the intercept on for house property type house different than the base case, which is apartments. Okay, and if you want to compare house to other, for example, and get a statistical test, then you would choose other as a base case, or you would choose house as a base case and make a dummy variable for the other property types. Okay, so what you found or what you can get from this is that you can get like you can perform a hypothesis test for intercepts and slopes between groups as long as one of those groups is the base case. Okay, so on to best practices. Then always think about the possibility of lurking variables, okay, confounding variables. Okay, so here you have to use logic and you have to use your knowledge of the specific market. Okay, so whenever you do or make an analysis, you have to know the market very well. Okay. So, use interaction terms to explore different relationships between x and y across groups. Okay. So, if interactions aren't statistically significant, drop them from the regression. Okay, that would be the x1 times the x2. Okay, drop them from the regression and rerun the regression. Without x1 times x2. Okay. But if interactions are significant, include the individual variables even if they aren't significant. Okay. So which means that you have to include x1 plus x2 in addition to the interaction term. So, and never include an interaction variable without its two components. Okay, that's a good rule. And be careful interpreting estimates on dummy variables and interactions, because the coefficients are relative, or differences from the base case. Okay. And last but not least, categorical variables are very common in data analysis. Okay, and they are very, very common. So, for example, in experiments, to look for differences between treatment groups and control groups, and you can use these categorical variables to make them more flexible. For example, you can you can capture seasonality with these categorical variables, and you can check for different intercepts and slopes. Okay, so that's it for lecture 9. See you next time.